Question 14 says the volume V of an enclosure contains a mixture of three gases: 16 gram of oxygen, 28 gram of nitrogen, and 44 gram of CO2 at an absolute temperature T. Consider R to be the universal gas constant. So what will be the pressure of mixture of the gases? So the weights are given to us in the question, so we can find the value of uh, the total number of moles that are present for each gas. Then we add that up, then we use PV equal to nRT, where N is the total number of moles, and therefore we get the pressure of the mixture. So number of moles of oxygen will be equal to atomic mass of oxygen divided by weight in grams, that is 16 upon 32, which is equal to half mole. Total number of moles of nitrogen will be equal to 28 upon 28, that is 1 mole. And now total number of CO2 will be equal to 44 upon 44, that is again equal to 1 mole. So the total number of moles that are present in the container will be equal to 1 plus 1 plus 0.5, that is equal to 5 by 2 moles. Now PV equal to nRT. So P is equal to nRT upon V, which is N is the total number of moles, that is equal to 5 by 2 into RT by V. Therefore total pressure equals 5 RT upon 2V.